Objective 7, using a neutralization equation, be able to calculate molar amounts, molar mass or volumes of unknown reactant or products. So I've got an example here for you that 30 milliliters of 2 molar H2SO4 is used to exactly neutralize 25 milliliters of NaOH, and I've asked 4 questions. So I'm going to go to the next slide here where I've got the question a little bit smaller, and then I've also got the balanced equation here. And I've noted that we've got 30 milliliters of the H2SO4, 25 milliliters of the NaOH, which is 0.0300 liters, if I hang on to my sig figs, and 0.0250 liters of the NaOH. And I know the concentration of the H2SO4 is 2 molar, and the concentration of the NaOH is what we were attempting to find by running this titration. So before we get to that, well, right away, I guess I asked, what is the concentration of the NaOH? In order to know that, I'm going to have to go ahead and find out how many moles of H2SO4 I had. So 2 moles times 0.03 liters is going to give me, since molar means 2 moles per liter, times the 0.03 liters, I will get 0.06, and again, if I hang on to my sig figs, which I'm not going to worry about too much here, just in the interest of space, be 0.06 moles of the H2SO4. And when I look at my balanced equation, I see I have 2 moles of NaOH for every 1 mole of H2SO4. So I should expect that I've got 0.12 moles of NaOH. Now, I'm not quite done with my concentration because concentration is moles per liter. So now I can divide that by the 0.025 liters that I have, and that will tell me my molarity. So if I go ahead and take 0.12 divided by 0.025, I'm talking about a molarity of 4.8 molar NaOH. Question B then wants to know how many grams of NaOH are in this 25 milliliters. So now I go ahead and take my molar amount I had 0.12 moles times the molar mass of NaOH, and I know that Na is 23, the O is 16, the H is around 1, so this is right about 40 grams per mole. So if I go ahead and take my 0.12 times 40 grams per mole, I'll just stick a 0 here so those decimals aren't confusing. The 0.12 times 40 is going to give me 4.8 grams of NaOH in the 25 milliliters. So then C wants to know how many grams of NaOH could I recover from a sample at 5.5 liters? Well, I could just set up a simple ratio for this. I know that 4.8 grams would be expected in 0.025 liters. So that I can set it equal to X grams in 5.5 liters. And if I go ahead and cross multiply and divide, I come up with X being equal to 1,056 grams. And finally, question D says, if you had 3.3 molar solution of NaOH, what volume of acid would be used to neutralize this? So if I take a look at it, if I have 3.3 moles of NaOH, that's moles per liter of NaOH, then I could go ahead and look how many moles I need of that. So 3.3 moles per liter, I can take times my 0.025 liters that I know I'm using, And that means I'm trying to neutralize 3.3 times 0.025. I'm missing a 0 there, but I'll get it in here when I do my calculations. So 3.3 times 0.025 means I'm talking about 0.0825 moles of NaOH I'm trying to neutralize. And because H2SO4 has 2 hydrogens on it, I only need 1 mole of H2SO4 for every 2 moles of NaOH I have. So this is only going to be 0.04125 moles of H2SO4 I need. And if I need 0.04125 moles of H2SO4, and it's got a molarity of, what was my molarity? 2 moles per liter. Then I can go ahead and take my, I'll find another line here. I could take my 2 moles per liter and actually I want to do this the other way. I want to take my 0.04125 moles times my 1 liter contains 2 moles. And when I do that, I'm going to get 0.04125, and I'm effectively cut that in half again. I should expect 0.0206 liters or 20.6 milliliters of acid to be used.